Right. In this section, now we have to turn to page 53, section 3.3. Right. In this section, we are going to simplify. Expressions which are having cosec x with the cosec sec and cot. So also sine, cos, tan also getting involved, right? And what you should remember is cosec and sec. Always, if you take those, they will be actually in this region, right? In this region. So between -1 and 1, they don't have solutions. That also you should remember. But cot and tan is all right because they will have this kind of a shape, and they are reaching minus infinity and infinity. And also sine cos, right? If you take, it is the opposite of that, so sine cos will be always in this region, 1 and -1. That also we should remember. And cosec x we should remember, it is 1 over sine, and also sec is 1 over cos, and cot is equal to 1 over tan. Also tan we can write sine over cos. Same way cot you can write as cos over sine. So those things you should remember in this section, and we are going to use that and simplify and do questions, right? So example 6 in page 53, right? Still we are in page 63. Example 6, right? Example 6, it says to part A, they are asking us to simplify sine theta, cot theta, right? Sine theta, cot theta, and sec theta. Right? Sec theta. So how are we going to write? Now this is a basic thing where we will know, right? Sine theta into cot theta we can write. Now tan theta is sine over cos. So cot is cos theta over sine theta, and sec theta is, we know, if it is s, c, cos theta. So when we come up to this level, it is very easy, right? So cos theta get cancelled off, sine theta get cancelled off, though the answer is 1. Right, now we will see part B. It says to, I will start it from here, right? Part B, it says to part B, they are telling us to find sine theta cos theta, within bracket they have given sec theta plus cosec theta, right? So we will see how we are going to handle this, right? The best thing is we will turn this into 1 over, right? So here we will get sine theta cos theta within bracket 1 over cos theta plus 1 over sine theta, right? And if you expand, you will see this will get cancelled off. So I will write that also. You will get sine theta cos theta over cos theta plus again sine theta cos theta over sine theta, right? Sine theta. So here cos theta get cancelled off and sine theta get cancelled off. Final answer will be, right, sine theta plus cos theta. Right, example 7 part A, right? It says to prove that this quantity is equal to this quantity. So you have to start from one side and go to the other side. So the easiest one is to start from LHS and somehow get cos squared theta. The reason is, now these things you can write cot theta is equal to cos over sine, cosec 1 over sine, like that. you can write and try to simplify, but this person you can write only 1 over sine squared theta, like that. So maybe 1 is equal to sine squared theta plus cosec squared theta, like that. Lot of, I mean, we have to invent things and try to come to this side. So better start from LHS. So we can say LHS, right, is equal to, now here we will turn this into cot theta, we will turn into cos theta over sin theta, right, into cosec theta means 1 over sin theta. So that we will write, and whole thing divided by sec squared theta is 1 over cos squared theta, 1 over s, if it is s it is cos, plus cosec means 1 over sin squared theta, right. Okay, so here we get cos theta divide, I mean numerator cos theta divided by sin squared theta, right, cos theta divided by sin squared theta, whole thing divided by, now here I will take these two as the denominator and cross multiply. So we will get cos squared, sin squared theta plus cos squared theta over sin squared theta cos squared theta. Sin squared theta, I will write in the order, same order, cos squared theta into sin squared theta, right. And also we know the most simple equation we learned, right, sin squared theta plus cos squared theta is equal to 1, that we learned right earlier. So here we can write that sin squared theta and cos squared theta has come, we can write that, right. So here this is equal to, again, cos theta, right, cos theta over sin squared theta divided by 1 over cos squared theta, right, 1 over cos squared theta sin squared theta, right. So I will bring to this side now. Here, right, again I will write the, division I will do like this, right, see whether it is all right. So here 1 over sin theta, when you take it, now this denominator it goes up, right. So here what we will get is cos theta over sin squared theta, right, cos theta over sin squared theta, whole thing divided by 1 over cos squared theta sin squared theta, right. Now we can make it we can make the division multiply and take this fellow up. So we get cos theta over sin squared theta into cos squared theta and sin squared theta. So, oh, something has gone wrong, we'll check. Sin squared theta goes off and I get okay, cos cube, right. Actually the beginning was wrong. What we have to prove is not cos squared theta, cos cube theta, here cube, right, cube. So here we get cos cube theta. So this is equal to RHS, right. So you all also actually go through this and then without looking at the answer try to prove, right. Now what we proved, this part A, right. Part B, they are asking us, right, they are asking us to show that this equation has no solutions, right. So how we are going to do is, so if this is true for all theta, right, then actually LHS is there, right. So for all theta, all theta, this cos cube theta should be equal to 8, right. Then we can say when in above, right, in above, right? Considering, we can say, part A, right? Part A, right? Cos cube theta should equal to 8, right? Cos cube theta should equal to 8, right? Then that surely this LHS should be 8. No, then we get cos theta is equal to 2. Now this can't happen, because cos theta is always, right, cos theta, right, cos theta, our normal graph, right, cos theta, right, always, like this, it has a wave and it is between 1 and -1. So this can't be. So then we can say no solutions, since, right, since always cos theta, right, less than or equal to 1 and greater than or equal to -1. So this can't happen, right? So that is how you should argue. Right, now we will choose some. Now that's all we have for example 8 is there. After that I will do the example 8. Now we have to do example 8 in page 55, right? Example 8, and part A is sec theta minus 2.5. So before solving this, I will show you how to solve these kind of things, sin theta, cos theta and tan theta. Right, now suppose we'll say sin theta is half, right? Sin theta is half. Then if you put this into the calculator, it will give theta is equal to 30 degrees. But there are several values, not several, infinite number of values. Now if you take the sine curve, right, it goes like this forever, right, and it oscillates between minus, now this is theta and this is sine theta, right? If you take, this is 1, this is -1. If you take half, right, half, there are so many places which it is cutting the cutting the graph, right? So how are we going to get this? So actually the calculator has given the acute angle, right, which is 30. Now there is another one, 150 also, sin 150 also, actually half. And also if you take this one, that is 2 pi, 360 and 390 also that. So how are we going to get? The idea is like this, right? When the calculator gives the answer, if you take the 4 quadrants, right, 30 he gives, right? But this 150 also, this 150 degrees also, now this is 30, right, that is 30 and 150. So we have to get the use of, right, sin 180 minus theta equals theta, sin theta equation, right? So hope you can remember. There are, we discussed sin 180 minus theta, sin 180 plus theta, cos 180 plus theta, cos 180. Okay, so like this we discussed. I will put in general form to remind you. Now the two angles are 180 plus theta and 180 minus theta. So here we have sin, cos, tan, right? Sin, cos, tan, sin 180. So the answers we will get is
right? Sine 180 plus theta, all STC, all STC. I'm doing this because I feel there are students who can't remember this also, some students, right? 180 plus theta, then it is minus sine theta, right? And if it is cos, it is again minus cos theta. Then tan, it is going to be plus, so tan theta. And if you think of sine cos tan for this one, right? Sine cos tan, right? So here you will have sine cos tan, then sine 180 minus theta is sine theta, sine cos 180 minus theta is minus cos theta, right? And also tan 180 minus theta is minus tan theta. And also there is another thing, minus theta, that also we will be using, right? So if you take sine cos tan of that, right, sine cos tan, you will have 3, right? So sine minus theta is minus sine theta, cos minus theta is cos theta, it comes here, and tan minus theta is minus tan theta. So we have to remember those also, when you are following these ones and these quadrants, what are the things, and also the graphs, right? Again I will so come here, but right now we'll say it is 30, right? It is 30, and I will draw this properly. So 30 is there, 30 degrees, and 150, right? So we will use this. Now we know sine, now we get 30 from the calculator, right? Then 180 minus 30 also is equal to sine 30, right, from our equation. So this is actually half, but from then here we know theta is 30, right? Theta is 30. Then sine 150 is equal to sine 30 is equal to half, right? So now the trouble is we found two angles. So when you are handling sine, this is the way you should handle, right? So we found 30 and 50, 150, and now keep on adding 2 pi for these two values, and subtract 2 pi from each one, then you will get all the other angles, right? So the actual all solutions will be, right, theta is equal to, right, 30, right, 30 plus 2n pi, and other one is, we can say, or we'll put it in one sentence, theta is equal to 30 or 150, right, and you have to add 2n pi. There are general solutions for sine cos tan, but I won't discuss that, right, because I don't want to step beyond step beyond our specification, right? Normally it is not discussed. Because of that I'm just doing this normal way, right? Now we will keep that here, right? Then we will discuss what about cos, right? Cos. So sine, I will raise this example also. Now this topic actually got diverted, right? So if you have sine theta is equal to x, right? Sine theta is equal to x. from the calculator you will find sine inverse x, and right, you will get theta 1 and theta 2. I mean, always there will be two values. So here theta would be, right, theta 1 or theta 2, right, plus or else we can do like this also. If it is theta 1, right, sine inverse x, we will get some value from the calculator, right? So what you can do is, right, sine inverse x, right, so we can put in the general form theta is equal to sine inverse x, right, sine inverse x, or pi minus sine inverse x. So these are the two values. If this is given 30 or 150, right, plus 2n pi, that means all the values of that. So this kind of you can assume for the, not assume, use for the sine inverse. Now we will check, right, now we will check if we get cos theta. If we get cos theta, right, if we get cos theta, we'll say cos theta is equal to we'll say 1 over root, no, we will take root 3, we will take half means 60, right, half, right. So now when we take the cos, now the calculator, right, cos inverse half, it will give, right, 60 degrees, right, 60 degrees, and then right, and then the cos, actually the graph will go like this, right. So we know cos 60 is half. Now it is the half sign, no need of minus, right, we'll put half. And if you take here 60 degrees, earlier actually 30, here it is minus 60. So if you add 2 pi's for these values, you will get all the angles. So, and what we are going to use is, right, we know, right, now if cos theta is half, right, cos minus theta also equal to half, right, that we are going to use. Then if 60 is there, cos minus 60, right, minus 60 also a solution, right. And also you would see 60 also going to be cos, right, cos 60 also going to be half, cos minus 60 also going to be half. Just now I discussed, no, right, cos, actually we know cos plus or minus theta is equal to cos theta, but all other two are going to be negative. Here all STC, cos is going to be this one, right. So now we can have, now if you we have to add 2 and pi for these two values. So what we can do is, whatever for cos theta we can have a general solution, right, general solution, we say cos theta is equal to half. Now here if cos theta is equal to x, right, cos theta is equal to x, we can say theta is equal to plus or minus cos inverse x, right, plus 2n pi. This also you should remember, right. And same goes for tan theta, right, same goes for tan theta, right. If tan theta is equal to x, right? Theta would be plus or minus, sorry, not plus or minus, that's the interesting thing, right? If we'll take example and see, right? We'll say tan theta is equal to, right, we'll say root, we'll say 45 degree, 40, we'll say 1 over root 3, 1 over root 3. And if you take the graph of tan theta, if you take the graph of tan theta, it will go like this, right? And now we know theta is equal to tan inverse 1 over root 3, and it is 30. So, but there is another thing, tan 180 plus theta is equal to tan theta. From that we get tan 180 plus 30 is equal to tan 30, right? That is equal to tan 30, right? And so tan 210 is equal to tan 30 also we have. If this is 30, now it is 30, right? 30. And if you take 180 plus 30 here, this angle, right, this angle 180, that is 210. So actually this is the straight line, right? So that angle also going to be tan 30. So and if you take those values here, I mean, if you thinking of the graph, roughly 30 is here, right? Then 30 and 30 plus 180, so this is actually 90, right? 90, then 180 means this length, so again it comes here, right? The shape is same, but the angle is little, I mean 210. Again another pi, right? So we have another equation for tan. So always when you add, I mean, if you take these two, and always if you take 2n pi's, if you take this value and if you take all 2n pi's, that is equal to this angle plus n pi's, right? Okay, so because of that we get a equation for tan theta like this. If tan theta is equal to x, right? Theta is equal to tan inverse x, right, plus n pi. So this also we should remember, right? And another thing we have to remember, right? Now when you take sine, cos, tan inverse, right, inverse, your calculator, right, if you take the, I mean, if you take the positive values inverse, for example sine inverse root 3 over 2, right, he will give 60, that is positive. But you have to be little careful. If you put these values, for example sine inverse root 3 over 2 minus root 3 over 2, right, and we'll say we will take the other one, sine, tan and sine behave same way. Tan inverse will say root 3 minus root 3, right? So here he will give root 60, so minus 60 he will give, and root 3 is then will, this is, yeah, this also he will give minus 60, right, minus 60, then root 3, yeah. But the cos, right, if you try some cos inverse, we'll say 1 over root 2. 1 over root 2, so that is 45. He is not going to give minus 45 degrees. The reason, then if you take cos minus 45 degrees, right, it is going to be positive 1 over root 2, right, because this quadrant is, because of that only cos, he will give the obtuse angle from here. That means I will 180 minus, right, we'll put another one, we'll put root 3 minus root 3 minus cos inverse minus, we'll say half, right, half. So we know it is 60, right, 60. So if it is half, what he is going to give is, right, now this is related to the 60 degrees, no, 180, so he will give 120 degrees. So what he will give is, because cos 180 minus theta is equal to cos theta minus cos theta, right, minus cos theta, right. So what he will do is, right, now 60 is there, right, now this is actually related to 60, then what he will do is cos, right, 180 minus 60 he will put here, so this is minus cos 60. Because of that, cos 120 is equal to minus half. So because of that, remember, always he will give the obtuse angle related in the second, if you take this first second quadrant, right, that also remember, calculator gives actually between now these values, cos inverse only will be in values greater than we'll say like greater than or equal to 0 and less than or equal to 180. Those values he will output. But for sine and tan, right, sine and tan, the range would be theta will be the minus value and the positive value range, right. So minus 90 greater than or equal to minus 90 degrees, less than or equal to 90 degrees, right. Today I am little sleepy and I'm struggling a little, right. Okay, so now you should have these ideas, and we'll now attempt the example 8. Right, now we will do the example 18, page 55, sec theta equal minus 2.5. So how we are going to handle this is, we will write this as cos theta is equal to minus 2.5, and then we will cross multiply. We get cos theta is equal to 1 over minus 2.5 or minus 1 over 2.5. So this is minus 4, right. Then what we have to do is, with the equation method also we can see, right. Now if you put this cos theta, right, cos theta, right, actually here it comes as minus 0.4, right. So now we will see how we are going to solve this. Now when you put this into the calculator, right, cos inverse minus 0.4, you will get, right, 113.6, right, 113.6 degrees, right. So just now, there are now two methods, or actually both are same, right. The equation method we discussed, right, if cos theta, right, cos theta is equal to x, right, then theta is equal to plus or minus cos inverse x plus 2n pi. So the other angle related to this 136 we can take like this. So the other one is, so theta is equal to minus 1136 degrees plus 360, right? So we get the answer is 246.4 degrees. And even if you look at the cos graph, right, even if you look at the cos graph, right, 113, right, now here this is pi over 2, that is 90 degrees, and here also 90 degrees, and 113 comes here, 113 comes here, and it is minus 0.4, minus 0.4. So from this actually we can see the other value we get it here, right? So that is 246.4 degrees. Now what you should do is, for this keep on adding 2 pi, and then you will get all the values. But here, right, they ask us the values between 0 and 360, 0 and 360, right, 360. So the only answers will be 113.6 degrees, right, or right, 246.4 degrees. The reason, if you add 360s to these two, right, 360s to these two, it will jump beyond this value. So because of that, these are the only two solutions. Right, now we will check part B, what we have to do. Right, we will attempt the part 2. I have put the equations. Right, so here actually x is the, sine value, and inverse is, this is the actually what the calculator gives you, right? So sine in here you will see sine inverse x, cos inverse x, and tan inverse x, right? Those are the values which the calculator is going to give you, right? That means if you put sine theta is equal to root 3 over 2, right, and theta is equal to sine inverse root 3 over 2, and if you put this into the calculator, he will give out a value. So that is what I have put here. So that value you should put this value into these equations and get the all the values. And also in exam, infinite number of values will come, but in the exam they will ask a range. In this range give the answers, right? So we will attempt now part B. It says cot 2 theta, right, cot 2 theta is equal to 0.6. So we can write this as tan 2 theta is equal to 1 over tan 0.6. So tan 2 theta is equal to 1 over 0.6. So that, this is 5 over 3, right, 5 over 3. Here you can consider 6 over 10, and that means 3 over 5, and opposite is this. So now what you can do is, right, 2 theta you can find using the calculator tan inverse, right, tan inverse 5 over 3. So the calculator will give 59 point
So this will give 59.03 degrees, right? Right, so 2 theta is this value. Then we can use this equation and add 180s, right? So 2 theta can have, right, 59.03 plus, I mean, we can't subtract 180 because it becomes a negative value, so we can say 180, that is valid, right? Then it comes to 280. And also now another reason, right? Now this is 2 theta. So if theta is in this range, 2 theta will be in the range of theta over, actually 2 theta will be in 720 degrees. So we have to take until that boundary, this one, comma, then we can say 59.03 plus another this one is 360 also, all right. And then we can take another value 59.03, right, plus 200 and, I mean 180, 540, still it is 590, 600, right, 600. And yeah, here 118, again another value we can get, right? Actually if you put 180, it goes beyond this, so only this value. So 2 theta can be, another thing we have to consider, 59.2 theta is equal to 59.03 also we have to consider. So this value, there are 4 answers. Then what would be the theta, right? You can divide this and add, the answers will be, it's there in the book, right? 29.5 degrees, comma 120 they have given, it's a rounded value, right? 120, 210, 3SF they have given, 310 and 300 degrees. So all these values represents 1 2 3 4 these values, right? Okay, so what I did was, whole equation I divided by 2. So we will do some questions. I will do some little difficult questions from the exercise 3C, which is on page 56, right? Question 1 part F, we'll try question 1 part F. So it says square root, right? Square root cosec cube theta, cot theta and sec theta. So actually what we have to do is rewrite the following as powers of sec theta or cosec theta or cot theta. So I mean we have to bring everything into one simplified answer, sec, cosec, cot, right? So we will see how we are going to handle that. Now here I see cosec cube is there, then right. So I mean, if I separate this, or else we will leave as it is, and then we will see this one. I can turn this into cot is, actually cot we can now here 1 over cos, right? Cot is 1 over sine. Then this, okay, I see a pattern. So what I will do is cosec cube theta into, I will write cot theta as cos theta over sine theta, and also sec theta I will write as 1 over cos theta, right? Then cos theta get cancelled off, this sine theta, 1 over sine theta becomes cosec theta. So here we can write cosec cube theta into cosec theta. Then we get square root of, right, cosec 4 theta, and this is equal cosec squared theta. Right. So then we will try 1G.
g it says, right, g it says 2 over root, right, tan theta. So how are we going to turn this by the sec cosec root? Then we can do this, right, 2, so this is equal to into 1 over tan theta whole thing square root. So this is equal to square root of cot theta, and if you want we can put half to the power, but we can leave as a this is actually a power of cot theta, right, 2 I mean, yeah, half to the power also okay. Now we will do this, right, part h. So here cosec square theta and tan square theta I will turn into sine square theta over cos square theta and into 1 over cos square theta, right. So here cos theta sine square theta over cos square theta cos theta. Then what we can do is here actually this goes off 1 over, so cosec square theta we can write 1 over sine square theta into sine square theta over cos square theta into 1 over cos square theta. Then this will get cancelled off. These two becomes, sorry, this is theta, these two becomes cos cube theta. So that is equal sec cube theta, right. So right, that question 1, that's enough. I'll choose another one. Right, now this one we have to simplify, right, we have to simplify. So the expression is I'll check again, sec squared theta cos to the power x to the power 5x plus cot x cosec x and sine 4x. So somehow we have tried to simplify this, right. So g here cos, here we can write 1 over cos squared x into cos 5x, so that part we see plus, right, cot, and this one we will turn into our normal form. So cot is cos x over sin x into cosec means 1 over sin x, and here we have sin to the power 4 Now we'll see what. So here it becomes cos cube x, right, cos cube x plus here there are 2 sin x and that will take off 2, so here we will have cos x into sine squared x, right, sine squared x, right. Here also there is another thing, sine squared x. Now from this equation sine squared x is equal to 1 minus cos squared x. I am going to turn everything into cos. So here we will have cos cube x plus cos x, and here 1 minus cos squared x, right, and I will take off the bracket. So here we will get cos cube x plus cos x minus cos cube x. When you expand it will become cube, he will be, so now this fellow and this fellow get cancelled off. Final answer is cos x. So here I will attempt the fourth question E, right, fourth question E, and actually we have to prove this, prove. So I mean I will take LHS and try to show the RHS. Other way it would be very difficult, right. So LHS we can write, LHS is equal to, now I am bringing this into the common denominator. So we will get cos x
cos x and cos x, I will write it. I mean, straight away I can write cos squared x, but I am not going to do that. And 1 minus sin x, that I will do because I don't have space, right? So divide by 1 minus sin x into cos x. So here we get, sorry, this is cos, right? Cos. Then we get cos squared x, right? Cos squared x minus, I will expand this, right? I will expand this. Then I will get 1 minus 2 sin x, right? I get 1 minus 2 sin x, right, plus sin squared x over this. Also I will, I don't know, I will just leave as it is. Still I don't know what to do, right? Sin x into cos x, right? So when you expand this, minus 1 will come, right? Again I will write it here. So cos squared x minus 1 plus 2 sin x plus 2 sin x minus sin squared x over 1 minus sin x and cos x. So we'll see whether we have a yeah, right? Now you would see cos squared x minus 1, I mean, yeah, here. So here you can have several methods. Here instead of 1, I mean instead of 1, you can put sin squared theta by sin squared x plus cos squared theta. So that also going to get simplified with these two. Or you can write here now 1 minus cos squared theta is sin squared theta. Instead of this you can write minus sin squared theta. Then it gets simplified from this. So I will do that part and then it will be easy. Here I will write instead of this I will write minus sin squared theta x, right? Then this fellow goes off and 2 sin x comes, plus 2 sin x minus sin squared x. I hope you all can see that, right? And then the denominator is there, right? That is equal to, we can write minus 2 sin squared x plus 2 sin x over our denominator, right? Denominator cos x, right? And then you would see, right, here, I will bring it to this side. Now if I take sin x out, from here, right, 2 sin x is common. 2 sin x if I take, right, I will get equal 2 sin x I am going to take out. Then I will get 2 sin x if I take 1, right, minus sin x. And denominator already we have 1 minus sin x and cos x, right, cos x. So here this whole bracket will get cancelled off and you will get sin x over cos x. So the final answer is 2 tan x. So you all can try different methods, right? Here when you come up to this level you can have different methods. Right, now we'll try another question. Right, I'll do the question, part F of question 5. We have to find the solutions between, right, 0 and 360, right? So we will try to bring this into, one sine ratio, so we can use this these equations. So here 5 cos theta is equal to 3 cot means cos theta over sine theta. Then cos theta get cancelled off, we get sine theta as 3 over 5, right? So actually now we have to use this equation, then therefore theta is equal to, right, we can write sine inverse 3 over 5 or sine inverse 3 or pi minus 180 we will write, then is, you know, right? So yeah, 180 minus sine 3 over 5, right? So all these values we can add to n pi, and we have to see what are the angles which are falling in 0 and 360. So when I put that to the calculator, sine inverse 3 over 5, we get 36.87, right? 36.87 or 180 minus 36.87, right? And we have to add plus 360, right, to n pi. Yeah, I mean multiples of 360, right? We can say n 360 n, right? And here so here we get theta is equal to 36.87 or 143.13 plus, right, plus 360 n. But the trouble is, if you add this or subtract, right, now if you can take the negative values also, if you subtract, it will go to the negative region or more than 360. So what we will have is n equals 0. That means only these two. So therefore solutions are theta is equal to 36.8 or 143.13 degrees. You can convert this into 3SF or whatever, right, and keep it properly. So that is question 5 part F, right? And then I will try, right, then I will try the 6th question H. Actually when you see this, you have to take this as a quadratic equation. So here we can write 2x squared minus x minus 5 equals 0, where x is equal to cot theta, right? And then we get we will factorize 2x x 5 and 1, or still we'll check whether we have roots, or do we have to take the b squared minus 4ac. It seems we don't have roots, right? So we will use this x is equal to minus b plus or minus square root b squared minus 4ac over 2a. Then we get x is equal to minus b means 1 plus or minus square root, right, square root b squared minus 4a and c minus 5. I have to put a multiplication sign, anyway 2, right, 2. Okay, so here we get 2a, that is 4, right? Then we get here minus, no, so 8 into 5 is 40, 8 into 5 is 40, then plus 40, then 41. So we get x is as 1 plus or minus square root 41 over 4. So we get 2 answers. We'll check those answers, right? So here from here I will take here, I will put now here, then cot theta is equal to 1 plus or minus square root 41 over 4, and tan theta, because we have only tan theta, 4 over 1 minus plus or minus square root 41. So you can put this into the calculator and find the two theta values, right?
So we'll see. Yeah, I'll put that in a calculator and see. Right. So here when we come like this, and cot theta is this, and tan theta will be this. So what I did was, right, now when I took the value of this from the calculator, it gives us two answers we are getting. Tan theta is equal to 0.5403, or when you take the minus 1, you will get tan theta 0.7403. So when I take the tan inverse, we get two answers, right? Two answers, that is this one or this one or this. We get two theta values. Now what we have to do is, now we are getting two answers. Those two answers we have to apply this equation, right? Always add pi's and check whether it is in the range of they are in this question. They are asking minus 180 greater than or equal to theta less than or equal to plus 180, right? So these are the angles, so keep on adding 180 and subtract 180 for this, and then you will get the final answers, right? Check that. I will erase this and put it. So final answers we get out of these two when you apply the I mean, here you have to consider plus in 180n, we will say plus 180n. Here also plus 180n. You have to put 0, plus 1, 2, 3, and minus 1, minus 2, minus 3, like that. So the answers you will get is H. Answers are minus 152 degrees, comma minus 36.5 degrees, and 28.4, comma 28.4 degrees, and 143 degrees. So including these two, right, including these two, you will get another extra 2 for this. I thought I will give some help for the 8th question, so you can continue. They have given a diagram like this and a circle, and they have given this as 6 centimeters, and ACD is like this. Part A they ask, right? Part A they ask, show that CD is equal to 6 minus sec theta minus cos theta. Sec theta minus cos theta. That is what you have to show. So the trick is, right now we should know this is 90, right? This is 90, and also if you consider this triangle, right, because this is the diameter, this also makes a 90 degrees. So this is a right angle triangle, right? So now how are we going to find CD? CD we can write, right? AC, CD is equal to AD, right? AD minus AC. So AD you can take from this ABD triangle. That is actually this is cos sec. So you will get AD as 6 sec theta. Please write the ratio and see this big triangle. And AC you will get AC. It is again, yeah, cos again. Wait, I'll check and let you know. Right, it is right, yeah. So this is the hypotenuse, then that is cos, so it will become 6 cos theta. So it is there, so you try to solve that. And then they say part B, right, given that CD is 16, right? So here we have equation, we will write now CD is equal to 6 sec theta minus cos theta, right? Now they say it is 16, and calculate the length of AC. Calculate the length of AC. So what you can do is, CD they have given, right? CD they have given, and then substitute this one as 16, and then find the theta, acute angle theta, and if you find that, you will be surely able to find the AC. It is 6 cos AC, right? I gave some help for the question 8. Now we'll see how we are going to approach the question 9. So part A I will try to do, and somehow we should get cosec theta here. Cosec theta minus cot theta 1 over minus cos x, all are x, right? Cos x, this is also x, this is also x, this is also x. So we will try this, right? So cosec x we have to we can leave it as it here, right? We'll turn this into cosec x minus, we will write as cot theta is cos x, right? Cos x over sin x, right? And divide by 1 over 1 minus cos x. This is LHS, right? LHS. And then if you cross multiply, if you bring this to the common denominator, right, this will cosec x and sin x will become 1. So here you will get, right, cosec x sin x minus cos x over sin x, right, whole thing divided by 1 minus, I will write like this, whole thing divided by 1 minus cos x, right, 1 minus cos x. So here you will see actually this is becoming 1. Cosec x is 1 over sin x. So here 1 minus cosec x. This will get cancelled off, right? This will get cancelled off. You will get 1 over sin x. So 1 over sin x you will get, and that is cosec x. And it is equal to RHS. I just gave some help. I didn't do it properly, right? So approach. Anyway, there can be other methods also. Now the other part is part B. Hence solve. So part B they are telling us cosec x minus cot x over 1 minus cos x equal to, we have to solve. So that means solving this is similar to solving, right, solving what? This is similar to solving cosec x equal to. So that means 1 over sin x is equal to 2, sin x is equal to half, and we know sin inverse x. So here we will get half is 30 degrees, and apply this for the first equation here. Now we found 30, 180 minus 30, and find take all the angles from here by applied 30 here. Take the angles between minus pi, right, and plus pi. That's what they want, right? I gave some help for the 9th one. We'll see now. 10th one also it's the same form. Write this sin x, tan x as sin x over cos x, and sin squared x you will get. You apply sin squared x is equal to 1 minus cos x. Like that you can solve. And the 11th question, we'll see whether it is difficult. I think it is also going to be in the same form, but just be careful the range. Now if you take the 11th question, the theta is in the range of 0 and 360. So when you are using these three equations, whatever the angles produced by these equations should be between this. I think we have completed the 3.3. So there will be another video for 3.4, maybe Tuesday night I will put, right, Tuesday night. Right, okay, we'll stop the lesson from here.